Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for two more long answer type questions in the chapter Current Electricity. Yeah, look at both question number 2 and 3. State the working principle of a potentiometer. So this particular question, first part of the question is same. State the working principle of potentiometer. So therefore, you divide these two questions as 3. So you concentrate the first part of the question first. Then thereafter separately, I'll explain the answers for the other part of the both questions. So first, state the working principle of potentiometer. Let us try to discuss the answer for question number 3 first. State the working principle of potentiometer. Explain with the help of circuit diagram how the EMF of two primary cells are compared using a potentiometer. So first let us understand the working principle of potentiometer. So potentiometer is a device. Potentiometer is a device used to measure the potential difference between any 2 points within a circuit. So this is without dragging current from the circuit. Next, the second is to measure or to compare, in particular, to compare EMF of two cells connected in the secondary circuit. Third is to determine the internal resistance of a battery. Battery connected in the secondary circuit. Okay. So first, and this is all without drawing current. From the circuit. So this is the advantage using potentiometer over voltmeter. Next. So let us try to understand the principle. Potentiometer consists of a wire. This is one of the standard resistance wire like constant or manganese, if possible nichrome also. Potentiometer consists of a wire of length 10 meters, which is divided into 10 parts, with each part of length 1 meter, and they are connected with using copper strips. So like this. And the potentiometer wire has uniform cross-sectional area. Okay, so you can understand 10 meter length potentiometer wire like this. 2, 3, 4, 5. You can take here 6. Okay. 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. This is 9 and 10. So how this is connected is connected with copper strip, connected with copper strip. So therefore, all the pieces are in series. This is NDA, this is NDA, this is NB. So between two ends, between two ends, A and B, a battery of EMF E, plug key K, and a series resistance, you can also call it as a rheostat, connected. So let resistance of the wire, potentiometer wire, let the resistance of the potentiometer wire is RW. Okay. So now, so here is the battery. So whichever the side you treat A, positive terminal is connected there, and B, so along with the rheostat, series resistance, and B is connected to negative terminal. So this is rheostat, variable resistance. So this is positive terminal, negative terminal, and this is key. Okay, so hereafter, let us concentrate on the principle. So here galvanometer is connected, and after that, the jockey connected to galvanometer slides on the potentiometer wire. So whenever the jockey is in contact with the potentiometer wire, so the circuit is closed. So then checking for zero deflection in galvanometer. So once it is noticed, then the potential difference between any 2 points. So this is potential difference between any 2 points is equal to total potential difference. So this is total length of the wire. Therefore, V, potential difference between any 2 points of length small l, is equal to V by capital L with L. So this is potential difference across the total length. Capital V is potential difference across the total length. So therefore, according to Ohm's law, I into R W, that is resistance of the wire, by L. So this is nothing but the principle. So you can write the statement. The statement is the potential difference across the length of the potentiometer wire is directly proportional to its length, or when a steady current flows or steady current passes through potentiometer wire, the potential drop per unit length, or you can also call it as potential gradient. Is constant. So potential gradient means potential per unit length. Potential difference per unit length between 2 points per unit length is constant. So this is the principle, but this has to be written both for question number 2 and 3 same. So after you write the principle, so let us continue. Explain with the help of circuit diagram how the EMF of two primary cells are compared. So you can treat this is entire 10 meter length potentiometer wire. Then these are the ends A and B. So there is a battery. Then there is a plug key. There is a rheostat. This is RH. This is battery of EMF. This is a positive terminal, negative terminal. And this is connected to end B. And here, this is secondary circuit. The secondary circuit is having 2 cells with EMF 1 and EMF 2. These are connected in parallel. So you can take a gap 1 and 2 here. And here there is one more. This 3 has to be connected 1. So there is a galvanometer. And finally, galvanometer is connected to jockey. So the primary circuit part is same. Secondary circuit. So in the secondary circuit, the EMF, the 2 cells whose EMFs are to be compared are connected. This you call it as key K1 and this is key K2. When both keys K1 and K2 is connected in the first gap. So 3 is connected to 1. K2 is connected in the gap 1. The jockey is placed at a different points along the potentiometer wire. For zero deflection. Then according to the principle, so instead of potential drop, E1 proportional to L1. So this is similar to potential drop proportional to L. So you call this equation 1. When the K2 now is connected in the gap 2, again checking for zero deflection in galvanometer. Placing jockey at different points. Then E2 proportional to L1. This is again based on the principle only. Call this the equation 2. Dividing 1 and 2. So therefore, you can compare the EMF of two cells. E1 by E2 is equal to L1 by L2. Then, moving to the answer for the second part of the first question. Because principle is same. So, till here is same for both the questions. Till here is same for both the questions. So, principle with the answer of the second part of the third question. Now, principle with the answer of second part of the second question. Now, so let us try to discuss the answer for the second part of the second question. Explain with the help of diagram how the potentiometer is used to determine the internal resistance of the given primary cell. Okay. So once again, you take, this is 10 meters length potentiometer wire. This is end B, this is end A, this is end B. So in the primary circuit, battery along with a key, 1 and a rheostat. So this is connected to end B. This is primary circuit, positive terminal, negative terminal, EMF. Yeah. So in secondary circuit, you connect a battery whose EMF to be, whose internal resistance to be determined in the secondary circuit, and a resistance is connected here. So once again, providing gap 1 and 2. So here 3. Then this is connected to galvanometer. Galvanometer is connected to jockey slides. So here you can write in the secondary circuit. In the secondary circuit, a battery, a cell of EMF, E, and a resistance capital R is connected in parallel. When key K1 and K2, so here key, this is key only, key K2 is connected in gap 1, checking for balancing condition in the galvanometer. Then according to the principle, once again, E proportional to L1. Now the key K2 is connected in gap 2, again checking for balancing, checking for zero deflection in galvanometer. Then potential drop across the resistance is directly proportional to L2. This is also again a principle of potentiometer wire only. So therefore, you call this the equation 1. You call this the equation 2, dividing 1 and 2. So therefore, EMF by V is equal to, you will directly get 2. So this is equation 1. Now, apart from this, when the key K2 is connected in the second gap, potential drop across the resistance wire, potential drop across the resistance which is connected in parallel to the cell. So then there will be the terminal potential difference. Terminal potential difference across the ends of the, across the terminals of the battery connected in the secondary circuit primary cell. So therefore, V is equal to EMF minus IR. So this is called a closed circuit. So when K2 is connected in gap 2, the terminal potential difference across the cell is V is equal to EMF minus IR. Now through the entire wire, same current flows, IR is equal to EMF minus IR. Then you can write this as IR plus IR is equal to EMF. Take out common I. This is going to be R plus R is equal to EMF. So once again, this I can be written as V by R is equal to V by R into R plus R is equal to EMF. Then finally, EMF by V, take V down, EMF by V is equal to R plus R by capital R. So equation 2. So comparing 1 and 2. So therefore, L1 by L2, EMF by voltage potential L1 by L2, that is equals to R plus R by R. So this can also be written as 1 plus small r by capital R. So take one left side. So L1 by L2 minus 1 is equal to R by capital R. Therefore, L1 by L2 minus 1 multiplied with R is equal to small r. So this is the desired equation. So you can also expect a numerical after you complete the answer of these two questions for 2 marks. So this is, that is already explained in the previous videos. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.